Hello, everyone, again. Thank you for joining today's session on data science. You might have heard this popular term data science popping up around lately everywhere, like be it in conversations, news headlines, or in your favorite apps and websites also. But what exactly is data science and how does it impact us, whether we are a developer, a tester, a business analyst, or even in non technical roles? Well, today we'll talk a bit about data science, machine learning, and some handy tools and languages used in it. Don't worry, I'll not lead you to the list of topics and all. Believe me, we are just going to explore this in a very easy, fun way with some real time examples. We'll start with a simple scenario. You just bought a new set of headphones on Amazon. The next time you log in, there is a section that shows the list of gadgets that might interest you. So, how did Amazon know what you liked? How did it suggest the items you're probably likely to buy? Think about your social media feed, maybe Instagram, Facebook. How does it know what to show you next in your feed? How does Spotify know your next favorite song? Like, have you ever used Netflix and when it recommends a show, have you ever thought, like, wow, how did they know what I would like next? That is data science in action. In these cases, data science is used to analyze your purchase patterns, your browsing history, your reviews to understand the trends and then predict what you might want next. Simple. Technically, it is a field that combines statistics, computer science, and other domain knowledge to extract insights from data, make prediction, and support decision making. But why should we care about data science? Because the scope of data science is not much larger than what you can imagine. Apart from the simple retail and entertainment industries we just spoke about, there are a lot many other areas where it is actually making a huge impact. In case of healthcare, it helps doctors predict patients' outcome and diagnose diseases earlier by analyzing their medical data like test results or patient history. In the financial institutions and banks, they use data science to detect fraud. They basically analyze the transaction data, your credit card statements and all to spot unusual patterns like which might indicate a fraudulent activity. In agricultural and farmers, they use data science to monitor the crop health, predict yields and optimize the use of water and fertilizers. In education, it is widely used because it is used to personalize your learning experience. By analyzing a student performance and then learning patterns, schools and platforms can adapt the content to better suit the individual needs based on each individual student and improve the outcomes. It is used even in energy and climate sector. It is used to forecast energy demand, detect fault in the grid, and improve efficiency. Smart meters, IoT sensors, these things generate huge amount of data which help in optimizing the energy usage. Even it is used to predict, analyze the weather patterns and track global temperature changes and model the impact of climate change. Recently, widely used even in military and politics because in military, by analyzing the data from drones, satellites and other surveillance systems, we can spot the enemy movements and predict threats. Like it can help you in cyber defense, detecting hacking attempts or other suspicious activities before they become an actual problem. Even in politics, it is used to understand voter preference by analyzing the social media, past voting trends and patterns and surveys. This will help them target the voters with personalized message or making the campaigns more efficient and focusing on the actual key issues. Before we proceed further, there are some common myths about data science. I don't know how much you have heard about it. Like one is that you need to be a math genius to know about it. But let me tell you, while there are some statistics that will help you out there, but again, there are a lot of existing tools that make working with data a lot easier. Another thing is that you might have heard it is all about coding and you need to be a techie and all for that. But again, that's not true. It's just about the understanding the problems and communicating insights. We have an idea of what data science is used for. Let us look at some key steps that are involved in it. First is the data collection. It is like gathering data from various sources. Think about all the data we are going to generate every day. Like it could be from websites, sensors, apps, and even surveys. For example, an e-commerce site might collect data about each customer's browsing history, purchase patterns, or even how much time they are spending looking at a particular product. Next, I will say data rarely comes in perfect form because there is something that needs fixing, be it missing values, errors, inconsistency, something like that. Data cleaning, I could maybe tell you like it is like cleaning your kitchen after a big party. You know there are things everywhere, but first you need to figure out what is worth keeping and what needs to go into the trash. Now, once the data is clean, what is the next step? It is to enhance it. This is where feature engineering comes in. It basically involves creating a new variables or new features that help the model understand patterns better. In fact, the good features often matter more than the algorithm itself you're going to use in the model. Let me tell you an example. Imagine you want to predict whether a customer will buy a product or not. Instead of just looking at basic details like age, income, something like that, you might like to create a new feature like did they visit the website in the last 7 days, or how many items did they look at during their last visit. These new informations will give you the model a better hint about what the customer is particularly interested in. Next is data analysis. Let me tell you, this is where the fun part begins, because analysts and data scientists, they dig into the data to find patterns, trends, and relationships. For example, they might analyze which items are frequently ordered together, like realizing customers who often order pizza often add garlic bread and soft drinks. So like this is like finding the patterns in it. Now we are done with the analysis. Next, it is important to present the findings clearly, usually through charts, graphs, or dashboards and all. Imagine you have your findings. Now you need to explain it to a colleague. How will you do that? You're going to do something which is visually appealing. So that is where you will use a pie chart or a bar graph to make it easier to understand at a glance. That is data visualization. The last but not the least is prediction and decision making. Finally, you have the analysis and all. You need to predict it. That is where they use models to predict future trends or make decisions. For example, they might build a predictive model to forecast the next month sales and all. Once the data makes the prediction, it is also important to analyze how well it is going to perform. That is where the model evaluation part comes in. Depending on the type of problem, we use various metrics like mean absolute error, accuracy, and all of that. That again will be based on the type of problem we are going to solve. I hope I'm not going too fast. If you guys are like on the track, just give a thumbs up in the like reaction balloon. Like I'll know you are there with me. That's all. Next, let me tell you, we cannot talk about data science without mentioning machine learning, because machine learning is basically a tool or a technique within data science that focuses on building models which learn from the data and make predictions automatically on their own. For example, have you ever used Google search and felt like it is almost reading your mind? Think of how the Google search gets better and more personalized over time. Like the more you search, the more the system is going to understand you and understand your preference, and then it will provide you a much better results. That is machine learning. Another example is the in your email inbox spam filter. The system learns over time which emails are spam or not based on your past actions, like marking them spam or not. One time you'll go and mark this as a spam, the other time the system will learn from your actions and it will understand, okay, this category will go into not spam. This again is done using machine learning algorithms. In simple words, if I need to tell you, it is like teaching a child to recognize objects. The very first time you will show the child picture of different animal, and over time they learn to identify those animals on their own. This is machine learning. Within machine learning, it is broadly classified into three types: supervised, unsupervised, and reinforcement learning. So supervised learning is where the algorithm learns from labeled data. You can think of it like a teacher is guiding a student, where the model is given both the input and the correct output during the training period. So it is sure about what it is aiming for, and it uses labeled data. Now, the next is unsupervised learning. Here, the data has no labels, unlike supervised learning. The algorithm will try to find structures or patterns in the data on its own. Imagine at your home you're organizing a bookshelf, but you don't know what are the categories beforehand. Once you start to organize your bookshelf, in the process of organizing, you will try to identify that these could be the possible categories. That is what is unsupervised learning. And third is reinforcement learning. This is where the learning happens basically through trial and error. The model learns by interacting in an environment and getting feedback. It is a feedback mechanism in form of rewards or penalties. This is basically used in robotics and gaming. Now, within supervised learning, there are main two types, which is regression and classification. Regression is where we predict a continuous value. For example, predicting a house price or predicting the stock market price. So for predicting house price, what you'll do, you'll use features like size of the house, the location, the number of bedrooms and all. In this case, the model will learn from the past data where the house price is already known, and then for the new house, it is going to predict the price. This is regression because it is predicting a continuous 1 point value. The next is classification. Simple. To understand classification, imagine it as a category or a label. So here, when we need to predict a category, we'll use classification. A common example is what we already spoke about, the spam detection in your email. So it is either going to classify it as spam or not spam. And whenever a new email is coming, the only two options it is going to have is spam or not spam. This is classification. The common algorithms used in regression are linear regression, decision tree, random forest, and all of that. And in classification, you have logistic regression, support vector machine, k nearest neighbor, and etc. Now that we know what data science is all about and the common categories over there, now let us talk about some tools and programming languages used in data science. The most popular, and I'm sure everyone has heard, is Python, because it is very easy to learn and has a very vast ecosystem of libraries like Pandas, NumPy, Scikit-learn, etc. All these libraries are specially designed for data analysis and machine learning. The next common one is programming language called R. It is a little less common than Python, but it is specially used for statistical analysis and visualization. It is very popular in academics and research because of its statistical library. After the programming languages is the database. To work with any data stored in database, you will need a language to manage and query the data, and that is SQL. It is essential for extracting and organizing information from a very large data set. Now that we have covered programming languages and database, let us talk about making the data visually appealing. That is when data visualization tools come in. Tools like Tableau, Power BI, they allow you to create interactive visualizations and dashboards without actually needing to write even a single line of code. These tools make you easier even for a non-technical user to understand the data and make decisions based on it. The next common thing under data science is Jupyter Notebooks. It's simply a popular tool for writing and sharing the Python code. Like it allows you to write code in chunks and like instead of running it as an entire part, you can run the code in chunks and visualize the data. Of course, a more popular one than this is the Google Colab due to its accessibility across the device. Now that we learned about data science, let us make this even more relatable to you. Whether you are a developer or a tester or a designer or a business analyst, you are already likely to be interacting with the data. You might not realize it, but you're already interacting with the data. For example, you're a developer. Data science can help you optimize the applications. For example, understanding user behavior helps the developers tweak websites or apps for a better user engagement. So here predictive models can help you decide what features you need to add next in that app or a website based on the user preference. Even testers can analyze the data to spot trends or patterns that might indicate bugs or other performance issues. For example, if there is a sudden increase in page load time, then testers can look into the data to identify the potential causes. For business analysts, I would say data science is complete goldmine because here with data analysis, you can spot trends that help shape the business strategies, like identifying the best performing team or understanding the customer preferences, and you can actually show it visually in data science. Next, understanding how users interact with websites, like where they are clicking most often or which page they are interacting more. These can help web designers to create a more friendly, user-friendly interfaces. Even if you're in a non-technical role, data science will help you make decisions a lot clearer. For example, understanding customer satisfaction through data or like tracking the performance metrics can guide your decisions in management, marketing, or customer service, and a lot. So before we actually wrap up, I want to quickly touch upon the career opportunities in data science. Like these are the most popular roles, and there are a lot other more roles, but I'll cover the common one. Data scientist, as the name suggests, uses machine learning. Statistical models are there, and the other algorithms to basically extract the insights and make predictions. They like work on the complex data problems and they need programming, statistics, and domain knowledge. Okay. Next is a data analyst. It is very similar role to a data scientist, but here they focus more on analyzing the data and generating reports. So a data analyst help the organizations to make sense of the historical data or make informed decisions. Like if you like working with numbers and tools or like normal Excel or even SQL, data analysis is the perfect fit. Next is data engineer. Data in the cycle of data science, the data engineer comes in the very beginning. They are more likely to interact with the data part. They design and build systems to collect and process data, like they play a very crucial role in ensuring that the data is accessible and usable for analysis. In the cycle, they come in the beginning. Then who comes at the end is the business analyst. They basically help companies understand from a business perspective. Like you already have the data, you have the analysis, but somebody needs to explain it from business perspective. Like often working with stakeholders to translate data into actionable insights that improve the business process. The last is machine learning engineer. This is for people who like want to specialize in building models and systems that can predict the outcome based on data. Like it's more inclined to the technical side. To maybe conclude with, like data science is essentially about understanding the data, finding patterns, and using those insights to make decisions and predict the future. Like I would say, data science is already a big part of our life. And believe me, its importance is likely to grow as artificial intelligence evolves with like technologies like smart cities, self-driving cars, and voice assistants like Alexa and all already shaping our future. Like whether it is analyzing the user behavior, improving the product, or making smarter business decisions, data science is everywhere. Like maybe with that, I'll conclude for now. Thank you for your time today. And now I'd like to open the floor to any questions you might have.
Yeah, Yashaswini, thanks a lot for a very informed session. When it comes to data science, see,
Yeah.
there are two aspects how our company personnel we are all working. Some of us work on specific applications. How data science will be useful there, because data science, according to me, is more useful when you look at it a holistic way at a company level, not necessarily because most of us are ingrained to single systems. So that being the case, how you think people can embrace data science in the application that they're working?
It depends on the application you're using. Maybe if you're, like I mentioned, for the different roles, like maybe if you're a technical person and you need to, you're a developer or something like that, you can actually use data science to improvise your code. Like, you know what the expectation is. So you're going to improvise the code based on the customer expectations. Similarly, like I mentioned, for a business analyst or a person like that, you can actually use data science for visual interactions and all. You can use that.
Yeah, for example, you're saying that the developer can get data from the application on which they're working, they'll be able to do it. But we are all working on older applications where they don't have such framework where those kind of data is getting collated. We give examples of Spotify, Google, and all that. They're all modern applications where framework has been built to collect the data. So as a developer, probably you can go there, take the data, massage it, do whatever you want, analyze, take decisions.
Initially, we would have access to some part of data, right? That data we can maybe like actually collect it, like analyze it, and integrating is a later part. Like you first need to have an access to that data and understand and analyze that. Once you're done with that, maybe we can look for ways to integrate it with our existing system, I would suggest.
Yeah, but I would leave it to the technical people. I'm not a techie, so
Okay.
but yeah. The utility of data science is more at an organization level, at a business level, rather than an application level, is what I have learned over the years.
Yashaswini, you
Yeah.
spoke about the model and training the system with data and all that. With these LLMs, like quite a few these days, if we give proper data, like the cleansed data to the LLM, they can handle this part, right?
Yes, if the like data cleaning is like you're going to clean the data and do that feature engineering and all to make the data like completely usable to the model. Once you're going to give it to the model itself can adapt it, like learn on the data like based on the input you have given, and based on that input it can create like the output it is going to create on its own. Like you're giving what is expected from the model, and it will learn on its own, and then it will predict the output or maybe classify the whatever input you have given.
Okay, I might have missed because I joined a little late. So, who does the data cleansing? Like even in case of a data science or a model that you develop and train, so the data cleansing has to be the key role, right? Key part.
Analyst, data analyst has to do it. There was 2 slides before she showed that.
Yeah, maybe I can go back to that.
No, it's okay. It's okay.
Ajit.
Yeah, and one more thing that probably would like to see is data science as a service. So that is what these large banks are trying to do because, as I said, data science, they want to build it at a bank level or at an organization level. And as Balaji was asking the question, like we feed in the data from individual systems, individual businesses. This data science service will do the work as you explained and probably respond back. I think that's how very large banks banks are all trying to develop.
Yes, like these steps and all are again on a high level. Like within each layer, there are like multiple process we need to do. Like this is just
Yeah.
an overview on a high level, I would say.
Hi,
Hi.
Yashaswini.
Yeah, hi.
Yeah, thank you for the session. And this part, the data science, is actually one of the most important part when we are learning AI. So when I learned AI, data collection and the data cleansing, whatever you said, right? So this was also there, and it was taught to us. It is really very important in order to use AI and to work with LLM, and to also answer Balaji and AC,
The other
that
AC.
yeah, the other AC. Correct. So the thing what I did in Doka is, I mean, not as a developer. So as a tester, I implemented some tools on Doka as well using AI. So first, what I did was I did the data collection. So the data what need for the automation test cases and the execution informations from the Jenkins and the test steps informations, those kind of things. I have collected it, and I have created a data data set for the AI. So first we need to create the database for us, and then we have to do the data cleansing and an analysis part. After that only we can able to give it to AI. So I think Balaji was asking this question, like whether this part itself will be done by AI. No, actually the data collection and the data cleaning, data analysis and everything should be done by a human, because AI will tend to hallucinate, and it still have a lot of struggles from the AI side. So it's not yet there 100%. So even the output with whatever is still getting generated by the AI is not 100% correct. So as Yashwini was mentioning the reinvestment learning, AI learns from this data, and it will get its data from here, and it will learn by itself. So once we get all the data and everything, human will be doing all these stuffs, and then we'll be giving it to the AI, and then using the reinforcement learning, AI will learn it by itself, but we have to give the feedback. So again, there comes the human part. So it really take some time for fine tune a model. Once the fine tuning is done, AI can able to run by itself, but it will take some time.
I'll put it in a layman's term right now. This is in the childhood. We all know once the child is 18 or 20, it's on his own. So maybe for next 4 or 5 years or something, there's a lot of human intervention. But after that, that is how I read all the articles, what is expected out of these kind of models. So these models will take over, and some new problem will come, and human will be trying to solve that new problem.
Yeah, exactly. Because the creativity is a human's intelligence. So AI cannot.
Right now it's in primary school. By the time
Correct.
it goes to high school and college, then they're on their own.
Correct.
But at one point, it is good that some control still lies with the humans.
Yeah, maybe not. I don't know.
So I hope this session sparked some curiosity within you. Thank you.